with Oscar class. That's my dad.
When we start looking at the volume of a sphere, we have to deal with the fact that there's really only one measurement that we need to worry about, and that is the radius. Remember, there are no surfaces here, so we're not stacking or shrinking. We're simply taking a point in space, we're finding all the points equidistant from that point, and then we're calculating the volume encapsulated by that collection of points. So the volume for this sphere is 4/3 pi r cubed. Now it's kind of fun when you get into advanced geometry or into calculus. You started looking at ways to actually calculate an area for that volume, which is using equations to establish where the center of the circle is, to establish its radius, and then to sum up all the various pieces as you travel out along that radius in order to create your sphere. It all boils down to this formula, 3/4 pi r cubed. It's not something we just made up. There's actual math to back it up. Check Wikipedia and you'll see I'm not just saying things here. Because Wikipedia is your first stop, but never your last stop in internet research. CBS cares. Now, in this case, I want the volume of this particular sphere. You also want to be very careful that you read the problems carefully. We are talking about a sphere here. If I were to be talking about a hemisphere, I'd only be looking at the half of a sphere. If you think of the northern hemisphere as the Earth, where we chop along the equator, everything above that is the northern hemisphere, everything below that is the southern hemisphere. In that particular case, what we're going to be looking at then is that half circle. So be very aware of what you're looking at when the problem talks to you. This is even more complicated when we do surface area because we have to account for that surface once we've sliced through the Earth or taken perhaps our orange and sliced through it. That will then create two half spheres and that surface there. Staying focused just on this particular sphere, the volume is 4/3 pi. In this case, I'm looking at a radius of 12. Common mistakes include using 24 because it's provided as a number in the problem. Always take your diameter, turn it into a radius. Calculator time. Let's see. I do 12 cubed, so 12 by 12 by 12. Multiply that by 4, and then divide. Darn it, hit clear a little early. Let's try that again. So 12 times 12 times 12 times 4 divided by 3. I get an answer of 2304 pi. And that then is the volume of this sphere in terms of pi, which is a perfectly acceptable way to leave your answer. Suppose I have a volume and I want the diameter of the sphere. The good news is because there's only one dimension in a sphere, that being radius, I can work the equation backwards. Volume is equal to 4/3 pi r cubed, so let's plug everybody in. 36,000 pi is equal to 4/3 pi r cubed. My first step is going to be to get rid of those pi's by dividing it out of both sides of the equation. That leaves me 36,000 on one side, 4/3 r cubed on the other side. Now I have to get rid of that fraction, so I'm going to multiply both sides by its reciprocal. Multiply both sides by 3/4, and that will then reduce this down a little bit. Let's see what we get here. I do 36,000, divide that by 4, multiply that by 3. I get an answer of 27,000. Now that's not 27,000 as an answer, that's what the radius would be if I cubed it. So the question now becomes, what do I do in order to get that down to a third power of what I've got, or the cube root of r would also give me this answer here. So I take the cube root of both sides. Remember, cube root is like square root, but for third powers. One side of the equation has r left. The other side of the equation gives me 30. So the radius of this mystery sphere must be 30 units, or in this case 30 centimeters. Be careful, you're not done. That's the radius. The problem called for the diameter, which means the diameter is twice the radius or 60 centimeters. Always make sure that you're providing the answer to the question that was asked, not the question you feel most comfortable answering. This last example, when we talk about volume of spheres, is to actually find the volume of a hemisphere. Remember, when we talk about hemisphere, we're talking about a half sphere, or a cutout section. So we take our globe, we slice through the equator, we pull off the northern hemisphere, and what's left? The southern hemisphere. Or you might think of this as half a grapefruit. Or if you're a car person, when we talk about an engine having a Hemi, so the tagline, yeah, she's got a Hemi, is referring to a half-sphere top of the cylinder, which creates more power on each downward push from the engine. This problem, by the way, is brought to you by Dodge. Yeah, it's got a Hemi. Now, I can go ahead and still do all the work I would normally do, 4/3 pi r cubed, except I'm going to be taking half of that when I'm done, because it's only a hemisphere, not the full sphere. So I really want half of that. So half of 4/3 pi, the radius is provided as 15 cubed. There's my formula with everything plugged in. Now all I have to do is start calculating and evaluating this expression all the way out. The good news is, I can, if I want to, multiply everything left to right once I've dealt with my exponent. I could also work left to right and just remember to multiply 15 in there 3 times because it's raised to the 3rd power. As a general rule, it's best to deal with that 15 to the 3rd first and then proceed with your multiplication. So 15 times 15 times 15, so 1/2, 4/3 pi, 3375. And now I have a collection of products that I can now multiply all the way through, or multiply and divide as shown. I'm going to go ahead and take that number there, multiply it by 4, divide that by 3, and then by 3 again, and I have an answer of 1500 pi. Now, I did include my half here to represent the fact that I'm penmanship matters. As you can see, I accidentally wrote down a 3 when I meant to write a 2. So make sure that when you're working, you show your steps clearly and that you write your numbers carefully to avoid these kinds of mistakes. CBS cares. Let's do that again now. 3375 times 4 divided by 6, not 9. I get an answer of 2250 pi. Units were given in meters, meters cubed. Now, as I said, because I've included the half in my equation, I don't need to divide by 2. I've already done that part. This would tell me the volume of a full sphere, add the half, and now I have the volume of the hemisphere that represents my core idea. Final answer, 2250 pi. You could, of course, make it into a decimal, but why add extra work for yourself when that answer is perfectly acceptable?